You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS Presentation 1256, OneNote Compound Intervals, Intervals over an octave. List of presentations. We plan on adding plenty more to them shortly. Also noting, within this OneNote presentation, we'll spend all of our time on the music theory side of things. However, we also have another presentation similarly numbered and named where we build these tables in Excel, practicing our Excel skills, our music skills, and table visualization at the same time. We're going to be continuing on with our interval practice. This time, we're going to be going in the clockwise direction or up in pitch over an octave, looking at a compound interval format, which means we can basically drop the notes. It's not the way I would prefer to do it, but it's what you might see in a textbook, and it's a little bit shorter because, again, you can kind of drop the notes if you compound the scale degree. But before we do that, let's go ahead and get a quick reminder of what we want to keep in mind so that the terminology, although not perfect, far from perfect, imperfect in many ways, doesn't throw us off from our objective, which is to visualize the fretboard as a map of the territory, having 7 continent locations on it, the non-continent locations of which there are 5 oceans. We go through to get to the continent location. We imagine ourselves in space above this low or heavy E string, the one closest to the ceiling. As we do so, we imagine the world of the fretboard spinning around. It is rotating like the Earth, like the planets. The planets are moving, but we just want to select a degree of rotation, typically selecting degree 4, which is the key of C and the related 7 notes, but everything would be the same if it shifted forward to the next note, C sharp, D, D sharp, and so on and so forth. So all of our intervals work over all of our collection of 7 notes, all 12 collections. As we do that, we want to keep in mind then the absolute continent names, not the note names, once we've got our degree of rotation, that being the Nashville number system, 1 2 through 7. So the Ionian is 1, the 3 is the Phrygian, the 5 is the Mixolydian, the 2 is the Dorian, and so on and so forth. Now remember that the scale degree system tries to pull us out of the optimal way to be visualizing the fretboard to be able to map out our territory. And that's what we want to keep in mind and not let it do that. Just like you don't let some crazy, super progressive person, drive you crazy with crazy terminology. And you're like, dude, just tell me straight, how far is it from here to the grocery store? And they start implying all these weird things about, like, you look funny or something like that. And you're like, dude, you have to remove all that stuff and just try to get the actual information that is somewhere hidden in all the weird terms that they're using that will actually get you to the grocery store. Because it's in there. It's just filled with a bunch of other garbage, right? You just got to remove all the other garbage. And like, okay, now I can distill it down to the actual directions. All right, so what we've done in prior presentations is we've taken our 12 notes, we picked the ones with our formula, the 7 notes we're going to work in, which is going to collection of notes related to the key of C by applying the formula of whole, whole, half, whole, 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 half. There's our 7 notes, and then we started to think about the intervals between all notes from any particular point, typically thinking about the C or Ionian node. And we saw that if there's 12 notes, we then have 12 different, or 1 through 11, plus the 0 that we're on, different steps or intervals, distances from any particular note before it repeats, before it goes up another octave. Now, the current system that we're using usually drops the note name and only uses the major or minor, because the major is what everything is based off, and everything else got kind of shoved into minor, and the perfects were also in the major, and so on. And then it's got the third, which is the scale degree. All the scale degrees are kind of off by 1 because they should have measured from 0, but they measured as a 1 in a scale degree system. So that's what we have. They usually drop the notes, which are kind of like the most important thing. So you just have to know if someone says it's a major third, that it's not, the third isn't 3 notes away. The third is the third scale degree, which actually means it's 2 modal half steps up from our 7 note collection because it's off by 1. And it actually means there's 4 notes up, even though they don't say 4, which is the most important thing. We just kind of have to know that. So that's, again, you're talking to someone in the grocery store. They're giving you coded language. They're implying all these things about you or whatnot, but somewhere in there, they've also implied the actual directions to the grocery store. So if you can decode what they're saying, then you might actually make it to the grocery store. That's what we have here. So then we said, hey, we could keep on going up in the positive over an octave. If we go up over an octave, then there's actually 2 units of measure that we're using. One unit of measure, if we add the notes, is the distance in notes. The other unit of measure is the distance in scale degrees. So my recommendation before was to say, hey, look, let's use the notes to help tell us whether we're going up past an octave, and then we'll keep the local distance for the scale degree. So I'll get into this in more detail in a second. But no, we also saw that we can go in the negative direction. Now, if I go in the negative direction, the scale degrees completely fall apart. So that means that the reason for that is because if I'm on this C, for example, if I'm on this C and I go forward, this, and I make that the 1, this next note is now the 2. It's the second scale degree, but it's actually only 1 modal half step, 1 note up from the 7-note collection in distance. The problem is if I go backwards from C backwards, you would think from a scale degree standpoint, you'd have to still make this the 1 or like the -1, right? And then this would be -2, which doesn't make sense because then you'd have to rename all the negative directions. So we don't have a good way to go counterclockwise because, again, the measuring system is, frankly, it's wrong, right? It's not the optimal measuring system. So when we went in the reverse direction, my recommendation is to add the notes of direction. I'm going -1, which I'm going to use the same interval as though I went clockwise around the block, even though I'm going counterclockwise. So the reason I point that out here, even though we're going clockwise, is that when I go clockwise past an interval, a textbook will typically then drop the notes and they'll keep on going clockwise. So in other words, if I have these same 7 notes and I go up an octave to like this 2, instead of going to this 2, I'm going to this 2. Instead of going from C to this D, I'm going to this D, which is another octave up. Well, I could count the notes between them and say it's another octave up, or I can continue with the scale degrees. If I make this the 1 on the scale degree, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will now be the 9, the 9th scale degree. And that's what a textbook will typically do, which you have to do if you drop the notes. So if you drop the notes, how are you going to differentiate between going a major second and a 14 note away, or a major second that's an octave higher? So from our analogy over here, notice if I go from this 2 to this 4, the distance is 1, 2. Now they're going to call it 1, 2, 3 because they made this the 1. But in any case, let's start the normal way. It would be 1, 2, like normal people would measure it. And then basically you go around the block. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one would be the 9 instead of that one, right? If you measured properly. And you could see that, but instead of calling it, and you could see that as time. So I'm still going to say the local distance would be 2 away, 2 modal half steps away. But then to pop it off the page, to give it a 3D dimension, I would think about that as time. The time it takes to go around the block again to get back over here is the added octave. Now, it would be nice, the easiest way to do this, if I went 1, 2, 3, is to say, hey, look, let me keep the 1, 2, 3 with the ocean in here, distance in notes, the note equivalent, and then I can keep the local distance in intervals, which would be if this was the 1, 1, 2, 3 this way, right? And the reason that's useful is because it's useful to see that something is like the major second. That gives me, I want to map out on the fretboard all of the relationships that have a major second relationship within my system. So even if it's going to be an octave higher. So this kind of gives the flavor. And then if you give the notes in distance, that also gives you the distance. But if you drop the notes, then all you can do is do what we have as a compound interval. So that's what you're going to see in a textbook oftentimes. Some people talk this way, more like jazzy people are more likely, I think, to use compound intervals. But it is a way to be more specific on the fretboard. It's not the way I would prefer to be more specific on the fretboard. And it still doesn't solve the problem because you can't go backwards that way. You can't really do a compound interval going in the negative direction because, again, although some people use negative intervals, negative scale degrees going backwards, most people don't because it gets all messed up. So that means you can't really have a compound interval going backwards. So the way to solve that problem to me is to actually list the notes that you're going backwards. But